students do that because occasionally I'll forget to start the recording, and so then you can bug me. Are you recording? Yeah. Yes, that's good. Please bug me about that. Okay, so chapter 1 is some like laying the groundwork for the language that we're going to use about statistics. So the nature of statistics. Okay, first is basics. Okay, and then these first couple slides, you're not going to be able to copy down word for word. So you're going to have to like listen and paraphrase in your own words. It's like brain on kind of note taking, right? Brain on note taking. You'll never be able to write this all down with the speed that I'm going. So the first thing is descriptive statistics. And this is methods for organizing and summarizing information. So making data's tables, or taking data, tables, graphs, charts, calculations of various measures. Okay, those are descriptive statistics. So here's an example. There's a baseball team. They played 153 games. They won 56. They lost 97. They finished 7th in the American League. And they were led and hidden by Bud Stewart, whose batting average was .279. So these are all statistics. All these values are statistics that describe the baseball season for this baseball team. Okay, so how would you calculate their losing percentage? How would you calculate to get another statistic, another descriptive statistic? How would you calculate the Senators' losing percentage that season? Hopefully we all can do that. Yes, ma'am. No, it's real. So 97 divided by 153. That'd be their losing percentage in decimal form, right? If you want it true percent, then times 100, right? Yeah, good. Okay, so what'd she say? She said 97. So that would be 97 over 153 times 100 would be their losing percentage. That'd be another descriptive statistic for this baseball team, whatever that number turns out to be. 60-something percent. So that's descriptive statistics. Okay, so then let's talk about some more definitions. Population and sample. A population is a collection of all individuals or items under consideration, and a sample is a part of that population from which we're going to get information. So here's a visual. Population is all the items or individuals, and then a sample is some of those, right? Some of those, and what we're going to do, we're going to use that sample to gain information about the population. So then this brings us to inferential statistics as opposed to descriptive statistics. Descriptive statistics are just tables, facts, figures about something that gives us a description. Inferential statistics is, this is the key, drawing and measuring the reliability of conclusions about a population. So inferring or inferring something about a population based on data from the sample. Okay, so inferential statistics. So do you see the difference between the two? Descriptive is just we make visuals. We'll crank out numbers that describe a setting or a certain thing that we're looking at. Inferential statistics is where we draw conclusions about a population just by looking at the sample. Only by investigating things about the sample, then we draw conclusions about the population. So that the definite or a great example of this is like voting polls. Get this fast here. So let's just go to election 2016. Oh, that's not what I want. Latest polls. So just the first one I come to here. Here's the Republicans, the first thing here. Republican presidential nomination. So they have a poll, and here's the poll. The average, this is the national average. Trump 34%, Cruz 20%, Rubio 11%, Carson 9.5%, etc. So these are percentages of the population who favor a particular Republican candidate for the upcoming election. Okay, so does that 34%? Did they ask everyone in the whole country who your preference is, and they got that 34% of everybody in the whole country favors Trump? No, right? What did they do? They took a sample. They took a statistical random sample of people, and they inferred all these national percent averages of preference of candidate based on a sample, maybe 1,000 registered Republicans or something like this. Okay, so that's inferential statistics. We're not gonna ask every single person in the whole country, who they prefer to get that. We're gonna take a sample, and then using legitimate methods, we can draw conclusions about what the whole population is going on with the whole population. So the perfect example of inferential statistics is national polling, right? National polling for elections. So statisticians analyze information obtained from a sample of the voting population to make inferences, draw conclusions about the entire population. That's what we're talking about. So that's inferential statistics. Okay, now here's another thing. Observational study versus designed experiments. Okay, so in an observational study, researchers simply observe characteristics and take measurements, as in a sample survey. So like if you give us a survey, that's an observational study. So you're just observing what data that already exists. Okay, designed experiment, researchers impose treatments and controls and then observe characteristics. Okay, so observational study, here's the key. Someone is observing the data that already exists. That's observational. All right, but in a design experiment, the data do not exist until someone does something, the experiment, that produces the data. That's the key right there. So observational study, data's already out there. We're just gathering the information. Design experiments, like, okay, let's set up some controls and let's do an experiment, and then that's going to create the data that we're going to analyze. Okay? Questions on that? Okay, so I want you to find a partner and introduce yourself, and I want you to discuss these three bullet points: population versus sample, descriptive versus inferential statistics, observational study versus design experiment. Take about 2 minutes. Talk about these.
Inferential is more specific because you have inferential design. population is a single. Inferential statistics just takes information on a single population.
Okay.
Yeah.
Okay, and then the observation is right. And observation studies
And an experimental
you have to do that.
pretty much. It's designed as very simple. Like you have 20 information.
Yeah.
We get A's.
Okay. Anybody have a question on any of these, the meanings for these things? Don't be afraid to ask. Yes, please.
I was wondering if you could elaborate a little bit more on descriptive statistics in reference to inferential statistics. I understand inferential is the sample, but how could you describe descriptive a little bit better?
So descriptive statistics can apply to a population or a sample. So we could say that everyone in this room right now is the population. We could set that this room is a population, okay? And then we could find our average age. We could find we could get a chart that tells all our different favorite colors. You know, we could take all kinds of information about us, this group as population as a whole, and those would be descriptive statistics, okay? Inferential statistics is when you're always taking apart a sample or a part of your population, and you're gathering data, you're analyzing the data about the sample, and then you're saying this is what the population is like. That's inferential statistics. The population is, we can conclude the population is like this to a certain degree of certainty, knowing all these things about the sample. So you're inferring about the population from the sample. Descriptive statistics is just numbers and charts and analysis that describes a population or a sample. It's describing. Does that help?
Yes, thank you.
Sure. Okay. So let's go on to section 1.2. So we talked about inferential statistics is figuring out some things about a population based on a sample. So how do we get a sample? So this principle called simple random sampling is a way of obtaining a sample. Okay? And so it's a sampling procedure for which each possibility of a sample of a given size is equally likely to be obtained. So if we're saying we're going to sample from our population here, do samples of 5, then how many samples? There's lots and lots of possible samples. So say myself and the 4 in the front row, say that sample of 5 from our class has the same likelihood as any other group of 5. Then it's a simple random sample. Okay. So there's no advantage or weight, more likelihood of any one sample than another. That's simple random sampling. Okay, so then there's 2 kinds. There's with replacement, simple random sample with replacement, and without replacement. So with replacement means that we're gonna a member of the population can be selected more than once. Without replacement is that once that person's in the sample, they can't be in the sample again. So without replacement, you're going to have all different members in that sample. But with replacement, meaning like we're going to pick the first item or person, and then we are going to replace them into the population so they possibly could get picked again. Does that make sense? We'll do an example of that. Okay. So here's, yeah.
So like with replacement would be like, say you take a sample of blonde-haired people with blue eyes, and then with replacement would be blonde-haired people with brown eyes. So, or would that be?
No. So it's with replacement is what happens when you're creating the sample. Okay. So here's an example. Let's do this. So here's the Teenage Mutant Ninja Turtles. Okay. The turtles are Donatello. We'll call that D, Raphael R, Leonardo L, and Michelangelo M. So we enlist a sample of all the samples of 2 turtles without replacement. That means that in every sample of 2, you're going to have 2 different turtles. So what's one of these samples of 2 turtles without replacement? What's one of the samples possible?
Donatello and Raphael.
DR.
DR.
Okay? See if you can make the rest of the list. So we want all the simple random samples of 2 turtles without replacement. So we're listing all the possible ways to get 2 of the turtles. Go, list as many as you can. Go, do it. Yeah, just write them down. Someone said LR. That's another one. ML. DL. MR. That's the last one. DM. Is that all of them? DR, DL, DM, RL, RM, LM. Yeah, so we weren't very systematic. Everyone's kind of, and that's fine. Everyone kind of shouted out the one that they saw. But to be systematic, you could go like DR, DL, DM. That's all the ones with D. And then RL, RM, and then LM. And I think that those are the ones we got. So this would be without replacement. Okay, what about then with replacement? So this is without. So now, with replacement means it's possible the sample could have the same turtle twice, right? So we're going to have all the same ones we had before. DR, DL, DM, RL, RM, LM. Then we're going to have more. What else are we going to have? Yeah, tell me. DD, RR, LL, MM. So now these are all the possible samples you could get if you picked a turtle to be the first turtle in the sample, and then you put him back into the pool. You replaced him into the pool before you picked the second turtle. And so then you could get the repeat. See that? So without replacement, it's all the groups of 2 with no repeats or the same turtle, not twice. And then with replacement, you have all those same ones from before plus the possibilities that you could pick the same turtle twice in a row. Does that clear it up? Does that make sense? Okay, so now you do this. You do this by yourself. Same turtles. List all the samples of 3 turtles without replacement. All the samples of 3 turtles without replacement. Be systematic in the way that you go about it, so that it's easier not to miss any. If you want to work with the person you talked with, you can kind of compare your answers. Okay, now that's an order. Compare with the person that you talked to. 3 turtles in each sample, right?
Yes, it says
And then
What was the last one?
L, you can see the half hour at the
you took
end.
that long. Okay.
Well, R.
Back up.
How many did you get?
4.
You should have gotten 4. DRL, DRM, DLM, and RLM. And then, so in the way you order, if you put LRD or MDR, it does. That's fine. But if these are the 4 samples of 3 turtles. These are the 4 samples of 3 turtles. Okay, so now if it's a simple random sample, then all 4 of these samples have the same likelihood of being the sample. Okay, that's what we mean by a simple random sample. Each of the 4 has this equal likelihood of being our sample of 3. So what are the chances, or what's the probability that the random sample is DRL, the first one? What's the probability of that? 1/4, 25%, right? So there's a 25% chance that if we took a random sample without replacement of 3 turtles, we would get the sample DRL. Okay, what are the chances that a randomly chosen sample contains Raphael and Michelangelo? Do it with your partner. So what the chances or the probability that a randomly chosen sample contains both Raphael and Michelangelo? So I hear people saying 1/2 or 50%. How did you get that? So what was your thinking? What do you have to think to do that?
Out of your 4 random samples,
Yep.
you have Raphael, Michelangelo, and the DRM, and Raphael, Michelangelo, and the RLM.
Right?
So that's 2 out of 4.
2 out of 4.
I'm bringing it down to 1/2, which is 50%.
Good. So the 2, so let's break this down. We'll do probability in a couple of weeks, but let's just, for now, what does the 2 represent? Right, so this is the number of samples, or so we'll just say the number of possibilities that meets our criteria, right? That meets our criteria. There's 2 of them. And what's the 4?
That's the total sample, the total number of samples.
Total number of possibilities. That's the generic, or this is just the basic way we think about probability. The numerator is the number of possibilities that meets the given criteria. 2 of those samples contain both Raphael and Michelangelo. And then the denominator is the total number of possibilities. So that's a crash course on probability. Questions on that? Okay, so don't write anything down here. So common method, and this is kind of outdated because we have computers, but it's still good to get the idea of generating a list of random numbers. And it'll used to use tables. Okay, tables. So we'll practice using tables. So this is a table of random numbers. It's organized by rows, and it's organized by and you can also look at it in columns. Okay, so there's the line numbers and the column numbers. So there's supposedly 24 of you guys in the class. So we want to make this random. We want to get a random sample of 5 class members. So you would each have a number 1 through 24, and we're going to use the table then to generate a random sample. So there's a lot of ways. There's a zillion ways to do this using this table. So let's do it using row 5. Okay. So we're going to come in here and use row 5 in order to get a random sample of 5 of you. So what do we do? So because it's numbers 1 through 24, we're going to take 2 digits at a time. So we come in row 5 here and we look at the first 2 digits, 31. Is 31 a number between 1 and 24? No, so we just ignore it. And then we go to the next 2. 46. Is it someone in our class? No. Ignore it. Next one, 64. No. 37. We're striking out here. 61. 94. 87. 29. 22.
Yes.
Oh, thank God. So the first, if we're using row 5 to generate a random sample, the first student in the sample is student number 22. And we keep going. 30. 52. 36. 71. 32. 05.
Yes.
Next is number 5. Student number 5 is in the sample. And we keep going like this. 38, 63, 45, 58, 82. Wow. Row 5 wasn't a good one. 77, 51, 83, 62, 52. Going to row 6. 09. So we had 22, 05, 09. Is that a 3? It's either a 3 or an 8. Doesn't matter. 04. Need one more. 38, 47, 40, 88, 15. All right, so after I got going, I started going fast. Does that make sense? So you're gonna, since it's all the numbers are 2-digit numbers, okay? We're gonna go and we're gonna take them 2 at a time, and we're gonna just keep going until we get a 2-digit number that is actually a student in our class. And so the first one we got was 22. The next one was number 5. The next one was 9, then 4, then 15. So that would be the random sample that row 5 would generate. Any questions on that? I'm going to give you more examples here.
Why did you use row 5?
Nope. So there would be, like I said, there would be hundreds of ways to use this table to generate it. I just picked one. Yep. So for instance, you could also do row 9, column 14, and columns 35 and 36. So row 9 would be just like what we just did, but instead you'd be starting here in row 9. Okay? So you'll do that in a second. Column 14 then would be, here's column 10, 11, 12, 30. Here's column 14. So instead of going across a row, you take 2-digit numbers by going down a column. And once you get to the end of the column, you'd go up to the next column and go down. And then another way to do it would be columns 35 and 36. So here's 35 and 36. So you could march down, get your 2-digit numbers across. So like the first possibility would be 56, then 76, 51, 17, 39. All right, until, like, so what would be the first? Yeah. Ah. So this would be going down columns 35 and 36. We'd start with possibly 56, then 76, 51, 17, 39. So the first in the sample doing it that way would be 17. And then you would keep going down. So why don't you try we got time. Do it all 3 ways. So column 9, column 14, or sorry, row 9 across this way, and then column 14 down here. Here's 14, this one, and then what I was just explaining, columns 35 and 36, which is taking your 2 digits horizontally, but then marching down the column. And I'll make this bigger. So this got a little tedious, so do it with your partner so you don't dig a hole for yourself. So do it together with your partner. So you're doing these, you're going to do these, row 9, 14, and columns 35 and 36. Work together so it's a little more fun. Yeah. Okay, so what's that a question of? So that's a question of something we talked about, right? So you get to the same number twice.
Yeah.
So that's a question of something we've talked about. We talked about what? Are we generating the sample with or without replacement? If it's without replacement, what do you do when you get to that number again? Skip it. If it's with replacement, what do you do when you get to that number again? You include it, right? So it depends on which way we're doing. Did I tell you? I didn't tell you, right? So I didn't tell you, right? So let's do without replacement. No, let's do with. Let's do with. So do it with replacement, just for kicks.
Oh, sorry. 36. Oh, are you there now? Yeah, there's nothing else after that.
Wait, what?
We did those in 12 and 14. Oh, okay.
By 12, 14,
And then also 8, 0, 8.
If I say column 14, then yes, single file. This is where you do the doubles. Yeah, so by column 14, I was saying just go single file down column 14 and then wrap around and do column 15. That's just the way we're choosing to do it. Does that make sense? It's just a different way to choose to do it. Agree with my number in row 9 sample? Agree with that? Sorry, column. Oh, what am I doing? What am I doing? What am I doing? That's column 9. Jeez. I see where you were confused. Row 9. 11. Okay, is everybody on task? Is everybody on task? I don't think so. Okay, are we all talking about math? Are we all on task? Okay, are we on task? Is everyone talking about math? Really? Okay, how about row 9 now? Sorry. Okay, this is good. This is a good lesson. I sound really smart up here, right? But I'm going to make mistakes. So don't hesitate to, if you think I'm going down a wrong path, you can speak up. I won't be mad. I'll be happy about that because then we won't dig a hole. Okay, so how are we on row 9 now? So column 14, I won't do that. And how did 35, 36 go? First one in that one? 17, we'll do blue. Then 8, 21, 7 is here, is that right?
18.
And 18, is that all of them?
Yes.
So there would be, using columns 35 and 36, would be those 5. Question about using a table to generate a random sample, So again, the moral is there would be hundreds of ways we could use this table to generate random samples, say of 5 members from our class, numbered 1 to 24. Yeah, please.
Kind of an out-of-the-box question, but say, for example, you start on row 5 and go all the way down the rows and you're not able to find a number. Do you start back up at 0?
So whatever method you, so whatever you determine. So it's the way you're generating the sample is kind of up to you. So maybe, one way would be to go back up to line 0, 0. Another way would maybe go and start with the columns. So once you're done with all the rows, now start going down the columns. Either would be legitimate because we don't know what the numbers are in there. So either would be a way of randomly getting the sample. Does that help?
Yes.
Sure. Okay, but so just the reason that we do this is not because it's the reason we do it today, actually do it, but just so you get a feel for what it's like to generate a random sample. Doing it manually gives you the idea of what it is. But this just talks about how computers do this in an instant, right? You just put in your criteria, I need, 12 numbers between 0 and 1,000. And boom, you hit a button and the computer just gives you a random sample, right? So if you wanted a random sample, practically in today's day and age, with our technology, you're going to use a computer random number generator, either like on the handheld calculator has it, your computer, or whatever. But the table thing is good because you're forced to manually do it and understand what you're doing, generating that sample. Okay, cool. So let's just quickly look back at my stat lab. You got your homework due tomorrow night. So if you go to once you buy the access and enroll in our course, remember the code is so it's on Blackboard, the code that you'll need. So here's upcoming assignments. So if you've never used my stat lab or my math lab before, see this right here, this little thumbtack? This takes you through a practice assignment of just like all the different types of questions there are and how to enter answers. So this might be a good thing to do first. Click on this link with the thumbtack, and it's just a practice kind of getting used to this online homework system. And it takes you through like 12, and you have to go really fast. And then once you're good with that, you're going to click on here, Chapter 1 Homework. These are 10 questions that all pertain to what we did in class today, of all different types of questions. And then, like I said, that's due tomorrow at midnight. So you got to, if you don't have my stat lab yet, you're not enrolled in the course, which is probably most of you, get on that today so you have time. This should take a half an hour at the most. Once you get started on the homework, it shouldn't take long. Okay? Notice number of times you can complete each question, 3. And with each one of those 3, sometimes you get multiple attempts, like on some free response. Each of these has 3 attempts. So like you get 3 attempts, and if you miss it, then it'll give you a new question with new numbers, and you get to do it again 3 times. All right, so it's not, you don't have to, just note that you get multiple tries and attempts. Just read the instructions. It's going to be different for each one, okay? It's going to be different for each one how it works. Because if it's like true or false or multiple choice with two choices, then you're only going to get 1 attempt on that question, but then you're going to get 3 attempts. Does that make sense? They'll give you a new question similar, and they'll do that 3 times. So just read carefully. If you have any questions, you can email me. Tomorrow night, midnight, this first assignment is due on my stat lab.